morning to you once again. We are still on linear equations, and this morning's session is on linear equation involving fractions. For linear equation involving fractions, we always find our LCM, and the least common multiple, that's LCM, you multiply through by the LCM to eliminate the fraction given. And always, if you are given bracket in the question, once you have eliminated your fraction, you multiply the number outside by the numbers within the bracket. After that, you group like terms. After grouping your like terms, you solve for your variable. So always for linear equation involving fractions, we find our least common multiple and we multiply through by the least common multiple. Let me use an example to illustrate this heading. 1. If 1 over 5x is equal to 20, solve for x. You see now, I've given you only one fraction, and always if you are given one fraction, the denominator of the fraction is always your LCM. So our LCM for this question is 5 because they gave us only one fraction. You multiply through by the LCM, which is 5 times 1 over 5x equal to 20 times 5. 5 goes here 1, 5 goes here 1. It's left with s equal to 20 times 5. We are having 100. We are having 100. Example 2. Example 2. Example 2. If 2 over 3 x plus 2 is equal to 1 over 2 x, solve for x. Now we have two fractions, and to solve this one we find our LCM. So the least common multiple for this question is 6, because by now we all know how to find our LCM. You multiply through by the LCM to eliminate our fraction. So this is one term, and always if a fraction is attached to a bracket, we take it as one term, but not two terms. This is also another term. So it becomes 6 times 2 over 3 x plus 2 is equal to half x times 6. 3 goes here 1, 3 goes here 2. So you have 2 times 2 x plus 2 is equal to 2 goes here 1, 2 goes here 3. So we have x times 3. So 2 times 2 we are having 4. X plus 2 is equal to 3x. So we use this number to remove our brackets. 4 times x is 4x plus 4 times 2 we have 8 is equal to 3x. Once we reach this stage, you group your like terms by grouping the one with variable to the left hand side of the equation. So it becomes 4x minus 3x is equal to, because this crosses, it becomes negative, equal to negative 8. So 4x minus 3x is x is equal to negative 8. We have negative 8. Solve for p in the equation below. In the equation below, 1 over 8 p plus 3 is equal to 1 over 4 2p plus 5 plus 1 over 2. Now I've given you 3 fractions, and you ask yourself, how many terms do we have in this question? So we have one term here, one term, and what? One term. So we have 4 main terms. So our LCM for this question is what? 8. And once we know our LCM, you multiply through by the LCM to eliminate our fraction. So it becomes 8 times 1 over 8p plus 3 times 8 is equal to 8 times 1 over 4, 2p plus 5 plus half times 8. 8 will cancel 8. It's left with p. 4 goes here 1, 4 goes here 2, 2 goes here 1, 2 goes here 4. So 1 times p, we are having p plus 24, 3 by 8 equal to 2, 2p plus 5 plus 2 goes here 1, 2 goes here 4. So 1 times 4, we have what? 4. So you remove your brackets. P plus 24 is equal to 2 times 2p, we have 4p, plus 2 times 5 is what? 10, plus 4. And once we have this, you see we can add this because they are like terms. So p plus 24 is equal to 4p plus 14. This stage, we group our like terms. It becomes p minus 4p. Because if a positive crosses the equal sign, it becomes negative. It's equal to 14 minus 24. So negative 3p is equal to negative 10. You divide through by the coefficient of p, which is negative 3. So we have p is equal to 10 over 3. And since this is an improper fraction, you change it to mixed or decimal, mixed fraction or decimal. So it becomes 3 whole number 1 over 3. 3 whole number 1 over 3. Let us take our final example under linear equation involving fraction. Final example. So example 4. Example 4. Solve for m in the equation below. In the equation below, 1 over 2 plus 1 over 3m is equal to 1 over 4. So you ask yourself, what is the LCM? The LCM. LCM for this question is what? 12. Is 12. So you multiply through by the LCM, which is 12. So 12 times half plus 12 times 1 over 3m is equal to 1 over 4 times 12. You cancel them out to eliminate the fraction. 2 goes here 1, 2 goes here 6, 3 goes here 1, 3 goes here 4, 4 goes here 1, 4 goes here 3. We have 6 plus 4 times m. We have 4m is equal to 3. You group your like terms. It becomes 4m is equal to 3. Once this crosses the equal sign, it becomes negative. So 4m is equal to 6 from 3, we have negative 3. So you divide through by the coefficient of m. So m is equal to negative 3 over 4. Even though I said this is the last example, but let's take this complicated question. This complicated question. 5. If 1 over 5 is equal to x plus 2 over 3, solve for x. One may say this question is a difficult question, but it's not difficult. It is not difficult. It is not difficult. Let me add this to it. So what is our LCM here? Our LCM for this question is what? 15. It is 15. The least common multiple is 15. So you multiply through by your LCM, which is 15. So this by 15 equal to 15 times s plus 2 over 3 plus 5 times 15. 5 goes here 1, 5 goes here 3. 3 goes here 1, 3 goes here 5. So 3 times 1, we have 3 is equal to 5. You put this one in brackets. You put it in bracket. You can't multiply 5 times x, 5x, and leave this 2. Always, if you have something like this, you group it in brackets. Plus 5 times 15 is 75. So 3 is equal to 5 times x is 5x plus 10 plus 75. So you group your like terms. You move this one to the left hand side. It becomes negative 5x equal to 10 plus 75 minus 3. So negative 5x is equal to 10 plus 75 is 85 minus 3, 82. We divide through by the coefficient of x, which is negative 5. Negative 5. So 5 goes into 82. So x is equal to 16 whole number 2 over 5 negative. So let us take this trial question so that we try our hands on it during our leisure time. Trial question. Trial question. If 1 over 8 p minus 2 plus 1 over 2 is equal to 1 over 3, 2p plus 5. I solve for p. I find the solution set. So we are now done with linear equation involving fractions, and I believe you have really enjoyed my lesson on this session. Thank you.